This video is a review, a reminder of rationalizing fractions that you're using in limits. And if it's been a while since you've had college algebra, you may forget how this works. So let's start off with monomials. I just want to show you one, and then we're going to move on to what you're typically doing in limits. So in the past, you were probably asked to rationalize the denominator. There was just good form about not having square roots in the bottom of the fraction or cubed roots or any kind of root. They didn't mind them in the numerator. That's considered okay, but in the denominator was not. And they would just automatically say you had to rationalize the denominator. And you would say, well, to rationalize a square root, which is what we're going to talk about today, you would want the square root of a square because that would give you a lovely rational number. And the fastest way to get a square is to multiply something by itself. So the square root of 3 times the square root of 3 is the square root of 3 times 3 because you multiply the insides together, which is 3. So in effect, these, if you think about this, is the square root of 3 squared. This square and the square root kind of cancel each other. So you'd multiply the bottom by the square root of 3, and you have to multiply the top by the same thing to be multiplying by a version of 1. So you'd have 4 square root of 3 over the square root of 3 squared, or the square root of 9, 4 square root of 3 over 3. This 3 does not cancel into that square root of 3 because the square root of 3 isn't a 3. It's some decimal, okay, if you run it on your calculator. Now, to clean up binomials where at least one term has a square root, rather like what's in your limits, we're going to fall back on multiplying conjugates. And conjugates were two binomials that had the same two outside pieces, both have an x, both have a 2, but one is plus in the middle and one's minus, and when you multiply them out, then these two middle terms, the two x's, zero out, and you end up with a difference of 2 squares. So multiplying by conjugates, where you have the same two binomials, but the sign in the middle is opposite, is going to help us. Okay, so we're going to start off with 4 plus, no, we're not going to do that on top. We're just going to have 4 over 4 minus the square root of 3. We'll do a numerator one later. So 4 minus the square root of 3 is a binomial. If you had thought, well, I'll just multiply it by a square root of 3, the square root of 3 times that square root of 3 would be the square root of 9, which is a nice rational number. But the square root of 3 times the 4, because it's the distributive property, would make that irrational, so we're not winning. So we are going to multiply by its conjugate, 4 plus the square root of 3, and what you do to the bottom, you have to do to the top as far as multiplying. So you're multiplying by a version of 1. Typically, on your limits, you don't actually want to multiply out this distributive because what you're hoping for in most of your limits is that this fraction is going to reduce somehow. So don't try to multiply out this distributive property, but do multiply out this two binomials, the two conjugates. So you would have 4 plus the square root of 3, because if you want to, you can always multiply this out later. But the bottom would be, and I'm going to write this out the long way, 4 times 4 is 4 squared. 4 times the square root of 3 is a positive 4 square root of 3, minus 4 square root of 3, minus the square root of 3 squared. So we're doing the FOIL method. So like we expected, these two middle terms zero out. You have 4 plus the square root of 3 over 4 squared is 16 minus, and the square root of 3 squared is 3. So you have 4 times 4 plus the square root of 3 over 13. Now, if by some odd chance this had turned out to being 4 times 4 plus the square root of 3 over something like 12, then these two would reduce. So since 4 won't go into 13, you could either leave it this way, factored, or some of your teachers may want you to multiply that out, but factored is usually pretty good. Okay, let's try one that's not strictly numbers. All right, I kind of gave you a hint in the last one where I said, no, let's not do a numerator right now. This one has the square root in the numerator. And in your days prior to limits, square roots or any kind of root in the numerator was considered acceptable and an adequate form, and we only worried about them in the denominator. But what we're doing in limits is we're trying to transform some function that perhaps we can't use the x value that they're asking us about because maybe it gives us 0 in the bottom. So we're trying to find ways to transform the function itself, and this is just one technique. It may or may not work, but it's a technique to try. And so we are going to rationalize the numerator. So the binomial, that is its conjugate, is the square root of x minus 1. Now, the top, we want to go ahead and multiply out because we are trying to rationalize the numerator. That's our goal. So the square root of x times the square root of x is the square root of x squared minus the square root of x plus the square root of x minus, actually it's 1 squared, but it's just 1. And these two zero out. And on the bottom, I'm not really wanting to multiply this out in the first place, but let's see what happens here. Okay, so what I have on the top is the square root of x squared is x, and 1 squared is 1. And this right here looks a little suspicious. It's the difference of 2 squares. So let's factor it. And we had the square root of x minus 1. And this x minus 1 cancels out this x minus 1. And you're left with 1 in the numerator, x plus 1, square root of x minus 1. So it's a good thing we did not multiply this all out, multiplying through. And it did have a little bit of a reduction, and this is as simple as we can get. Now, in the past, if you had a square root, like down here, in the bottom of a fraction, it was not allowed to stay there. That could not be your final answer. But if you multiply that by its conjugate, you're going to start working your way back up to this original problem. So this would be okay because the instructions or the need would have been to rationalize the numerator. So if that's what you need to do, this is okay. So some students, it makes them rather nervous, because ever since high school, junior high, they're told you can't have a radical in the bottom of a fraction. You can't have a radical in the bottom of the fraction. You can't have a radical in the bottom of the fraction. And then you get to calculus and they go, it's okay. You can have it there if it's not bothering anybody. Okay. Now some of your teachers may have you do a few more rules than that, but the calculus part's kind of like if you're needing to rationalize the numerator, having a radical in the bottom of the fraction is necessary. And so we just sort of have to deal with it. One more. Square root of x plus 1 minus 9 over 3. This 3 does not cancel into that 9 because 9 is not a factor of the square root of x plus 1. So even though it's tempting, it does not cancel. Now let's rationalize the numerator, and its conjugate is the square root of x plus 1 plus 9. So we multiply the denominator by that as well, so that we're multiplying by a version of 1. We are going to go ahead and FOIL out these two binomials. So the square root of x plus 1 times the square root of x plus 1 is the square root of x plus 1 squared. And you may not want to put the square root of a square. You could just do it in your head, and that's perfectly fine. But I just am trying to remind you about how this works. And then we would do the outside 9 times the square root of x plus 1 inside last. Okay? And we would have 3 times the square root of x plus 1 plus 9. So the square root of x plus 1 squared is x plus 1. These two zero out, and you'd have minus 81 over 3 square root of x plus 1 plus 9. So this is x minus 80 over 3 square root of x plus 1 plus 9. And this would be our new version of the original fraction if we wanted to rationalize the numerator. Now, that should help you if you had just a little bit of rust. You need to dust off on your skills of multiplying out conjugates and how you pick them. And now you need to go back and do some limits.